Okay, so Hurricane Milton's out there. And yeah, it's got everybody a little anxious, especially with all this talk about potential storm surge.
Yeah, and I get it. It's one of those things about hurricanes, right? It can be a real game changer.
For sure, but that's why we're here to break it all down. We're going to dig into the how and the why of storm surge, look at those projections. Basically, we're going to make sense of all this together.
And you know what's so interesting about hurricanes, especially one like Milton that's still developing? It's incredible how such a small change in its path can have a huge impact on the storm surge risk.
It's true, like a hurricane's version of location, 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 huh?
Exactly. We could see completely different outcome depending on, just a tiny shift in its path.
Okay, but before we get ahead of ourselves, let's make sure everyone's on the same page about what storm surge actually is.
Right.
You know, just in case anyone out there needs a little refresher on their hurricane lingo.
Sure. So imagine this. Picture a massive bucket of water, right? And someone just comes and throws it at the coast.
Yeah.
That's kind of what storm surge is like, except instead of a bucket, it's the entire ocean being shoved around by the hurricane's winds.
Yeah.
It combines with the regular tide, and bam, you've got these crazy high water levels flooding in coastal areas, causing major damage.
Storm surge is not something you want to mess with. And it reminds me of Hurricane Michael back in 2018. Now, I know it hit the Florida Panhandle, which is a different area than where we're looking with Milton, but there's a huge lesson from Michael that applies to what we're talking about.
Oh, absolutely. And you hit the nail on the head there. You see, it's all about which side of the hurricane you're on relative to the eye and the direction of the wind.
Okay, so explain that. Why does that make such a difference?
So hurricanes in the northern hemisphere spin counterclockwise, right?
Right.
On the right side of the storm, the winds are actually working with the hurricane's movement, pushing water towards the shore, which makes that storm surge way worse. But get this, on the left side, the winds are blowing against the hurricane's direction. It's like they're trying to hold the water back.
So it's like a giant tug of war with the coastline caught right in the middle.
Exactly.
And with Michael, the areas to the left of the eye dodged a bullet, relatively speaking. They got a much smaller storm surge because of those offshore winds. Which brings us to why everyone's so on edge about Hurricane Milton's projected path, right? Because even a small shift could be a huge deal.
Exactly. And that's what we're going to look at next, those different potential landfall scenarios.
Okay, so let's get down to the nitty-gritty here. We've got these two possible scenarios, two potential paths for Hurricane Milton. What happens if we sort of game these out? Imagine the impact of each one.
Right. So let's do that. In scenario number one, let's say Milton decides to pay Madeira Beach a visit just north of the Skyway Bridge.
Yeah.
Scenario two, it's Bradenton Beach, just south of that bridge. Now, just for this little thought experiment, we're going to say Milton's bringing its A-game, hits with that maximum potential surge of 14 feet.
Right.
Worst case scenario kind of thing. But it helps us understand the range of possibilities.
Right, like turning the dial all the way up to maximum intensity just to really grasp what we're dealing with. Okay, so same hurricane, two slightly different paths, but potentially completely different outcomes, especially when we start talking about specific spots along the coast. So let's start with scenario one. Milton takes aim at Madeira Beach. Hit me with it. What kind of surge are we looking at for, say, Newport Richey?
So up in Newport Richey, they're probably looking at about 4 feet of surge if Milton makes landfall up by Madeira Beach.
Okay.
Now, if we go down south a bit towards Tarpon Springs and Clearwater, that surge, it gradually increases a bit, 5 feet, maybe even pushing 6 feet. But then things start to get really interesting as we approach St. Pete Beach.
Okay, how so?
We could be talking about a surge of 11 feet.
11 feet. Wow, now you're getting my attention. So what does that mean for St. Petersburg itself?
Yeah, St. Petersburg's definitely got their eye on those numbers, and for good reason. They'd be looking at about 9 feet of surge in this scenario, and further into Tampa Bay, like right around downtown Tampa, Harbor Island, they're staring down the barrel of that maximum 14-foot surge.
Okay, so if this first scenario plays out, Tampa Bay is looking at some serious flooding. But what about those areas a little further south, down towards like the Sarasota area, Fort Myers? Do they get a break?
They do see a bit of a decrease, but, it's all relative. Still talking about some big surge levels. Anna Maria Island could see around 13 feet, Longboat Key around 11, and then as we keep heading south, it starts to taper off, so Venice might see around 7 feet, and then way down south on Sanibel Island by Fort Myers, maybe around 5.
Okay, so definitely a gradient of impact here, even within the same scenario. The closer you are to that northern landfall, the higher the potential surge.
All right, let's flip the script scenario 2. Milton sets its sights on Bradenton Beach. What changes? Well, this is where that counterclockwise rotation we talked about really comes into play. Remember how those winds on the left side of the storm can actually work against the surge?
Right.
Well, with a Bradenton Beach landfall, areas like Newport Richey, Tarpon Springs, they're on that quieter side of the storm. They're breathing a sigh of relief, looking at a much more manageable 2 to 3 feet of surge. Even Clearwater gets off pretty easy, maybe 4 feet.
So just by shifting that landfall south of the Skyway Bridge, those areas go from a pretty significant surge to something way less intense.
That's right. And it gets even more dramatic as you look further south. St. Pete Beach, which was facing 11 feet in our first scenario, now looking at maybe 5 feet of surge. St. Petersburg goes from 9 feet down to 5 feet. It's a huge difference.
That's incredible. It really highlights just how crucial the exact track of the hurricane is. Seemingly small changes can have this huge impact. What about the areas south of the Skyway Bridge that caught a break in that first scenario? How are they looking in scenario two?
Well, the tables have turned a bit, haven't they? Now, those areas south of the eye are the ones on the side with those winds pushing the water towards the shore.
Yeah.
So it's not a uniform increase, but they're definitely facing a higher risk now. Madeira Island, they're still looking at a pretty big surge, maybe around 8 feet. Longboat Key, though, they jump up from 11 feet in that first scenario to a potential 13 feet.
So it's like the risk has shifted south along with the landfall.
Yeah, exactly. And that continues as you go down the coast. Venice, which saw maybe a 7-foot surge with that Madeira Beach landfall, now they're looking at a potential 10 feet. Sanibel Island goes from 5 to a potential 7 feet. So definitely a different picture in scenario 2, especially for those areas further south.
Wow, so two potential paths for Milton, but what feels like two completely different maps of potential impact up and down the coast. It's crazy how much a small change in direction can influence where those biggest dangers are.
It's true.
You know, it's easy to glance at a hurricane map and be like, oh, as long as I'm not right in the middle of that cone, I'm good. But as we've been seeing, it's way more complicated than that. It's not just will it hit, it's how will it hit.
Yeah, especially when you factor in that storm surge.
Totally. And speaking of which, we keep mentioning this cone of uncertainty, this phrase. I think we should probably unpack that a bit. What does that actually mean for someone at home who's trying to wrap their head around this storm?
You know, it's funny because that name, Cone of Uncertainty, it's kind of misleading. It's not like the hurricane itself is unsure where it's going.
Right, right.
It's more about the limitations we have in predicting its exact path.
Okay, so it's like a weather forecasting limitation thing.
It is. Think of it like trying to guess where a leaf will land on a super windy day. You know, you have a general idea, but those little gusts can really throw things off. So the cone gives us a range of possible paths, but that actual track, it could shift within that cone, and those shifts, even small ones.
Okay, that actually makes a lot more sense. So it's not necessarily about panicking if you're in the cone, but it's about understanding that that cone represents a lot of different possibilities.
Yeah.
Okay, so let's talk about that surge again. I want to make sure we're crystal clear on why it decreases so quickly as you move north of the eye. You move north of the eye, boom, suddenly that water's not piling up as much. Why is that?
Yeah, it all goes back to that counterclockwise spin. So on the right side of the storm, the wind direction and the hurricane's forward motion, they're working together.
Like a 1-2 punch.
Exactly. Pushing that water towards the shore, creating that surge, that huge bulge of water. But as you move to the left side of the eye, the wind direction changes.
Right.
Now it's blowing against the hurricane's movement. So instead of piling up the water, it's actually working to flatten it out, reducing the surge.
So it's like the hurricane is this giant, swirling water pump pushing and pulling at the ocean.
That's a great way to put it. And the closer you are to that central pump, the eye, the more intense those forces are.
Okay, that makes a lot more sense. So much to think about. We've covered a lot of ground here, talking about those potential landfalls, really dissecting this whole storm surge thing, and of course, wrestling with that cone of uncertainty. So as we wrap up, what are the key takeaways you want our listeners to remember, especially if they're in a potential impact zone?
Well, first and foremost, stay informed.
Right, of course. Yeah.
We've used models, historical data to paint these scenarios, but Hurricane Milton is still doing its own thing out there.
Right.
Check the National Hurricane Center, get the latest forecasts, see what its track is looking like. But I think even more important than that, and this goes beyond just this hurricane, is that understanding the science behind these storms, even just a little bit, can really help you make safer decisions. It's not just about whether a hurricane is coming, but how it might impact you specifically.
It's about understanding the nuances where those hidden dangers might be.
Exactly. So pay attention to your local officials. If they issue evacuation orders, listen to them. Those orders aren't random.
Right. It's based on all this stuff we've been talking about.
It is this understanding of hurricane behavior, that storm surge, and yeah, those potential what-if situations we've been discussing.
Well said. And on that note, one last thought for everyone out there to ponder. We've seen how even the tiniest shift in a hurricane's track can totally change the situation. What do you think causes a hurricane to swerve like that, even at the last minute? What are those little forces that could send Milton on a slightly different path? Something to think about. Stay safe, everyone, and we'll catch you next time.